now group 2, and we are going to present to you Nordåsvannet that we like to call dead or alive. We have me, Kristoffer, we have Maja Torbjørnsen, Albert here, and Oda, and Sepide. It will only be me and Sepide talking because if not, it will be way too messy. So, where we were, that's the important part. Here we have, if this one was working now. Oh, there it is. This is the west coast of Norway, as you can see. Here's Bergen. And a bit close up, we have here, up here, that's where we are now. This is the Bergen city center. And all in part of the red box there, that's Nordåsvannet. So that was where we were. And fun fact is that up here is where the king lives when he's coming to Bergen. He has this cool castle that we'll come back to that. So in the circle, that's where we were sampling. And the fun thing about Nordåsvannet is that it has a water exchange with the Grimstad fjord that's outside. So it's not just a separate lake, it has a tiny gap there. That's very important. So our site 1 was up here at Kyrkjetangen, a really cool place. Our site 2 was down here at Kyrkjetangen. It's a bathing place. And our site 3 was also at Kyrkjetangen, just a bit more south. So, introduction. First I want to talk to you about the history of Nordåsvannet. Because in the 1940s, we had this outlet of sewage where they had very poor directives about how they should do about the sewage there. So they started pumping the sewage directly with pipes into Nordåsvannet, and that of course was very bad. But they had a plan. They were hoping that Nordåsvannet, that is stratified, that all the shit basically would go down to the bottom and just stay there. So they were kind of like swooping it under the rug. We don't want to care about it. They failed a bit. So one of the winters in, well, only winter in 1969, there came a turnover because Nordåsvannet on top here is fresh water, so that froze over. And when this heavier salt water forced its way through, it turned a big turnover. It was like in water column. So the problem here is that all the anoxic sediments down there was suddenly moving upwards, and that was of course bad for all the organisms that was in there. And they had nowhere to go since there was a frozen layer of ice here, so they died. And when the ice melted, all the organisms and all the anoxic sediment come up of the surface, and you know what? That smelled bad. So we have here this inside information that we didn't know when we were first out there sampling. So we had actually very great expectations in Nordåsvannet. We were expecting action. We were expecting like stuff we have never seen before. But the reality was quite different. We found crab and litorinas, not very much fun stuff. So it was a bit more sadder for us when we went there. But this is what we did. We were taking a lot of photographs here. That is Uda taking a picture of sea stars. You can't really see them well here. But they were everywhere in the bottom. We have Albert here taking water samples for E. coli and phosphorus. We have Maja with her fancy equipment taking conductivity, salinity, and temperature measurements. And me and Caroline, we were doing quadras for biodiversity and sediment samples. We also have Sepide here overseeing, taking notes, preparing plankton nets, so we can take plankton samples. And we were having a lot of fun in the lab afterwards.
Let's see what we have. In site 1, which was surrounded by boats, houses, and hospitals, it was so close to the highway. We measured the temperature at 2 meter depth, 1 meter, and on the surface. The temperature was somehow constant, but a little bit cooler on the surface. The pH showed us we had a basic pH at the 2 meter depth, and we had a basic pH on the surface. We had a gradient of salt at this side. So we had the fresh water on top and the salt water at the bottom. The phosphorus level at this side was awful. High level of phosphorus at the bottom and the moderate level of phosphorus on the surface. The TCD at the 2 meter depth was okay, but it was really, really high on the surface. And we think that because we found the stream which import its outlet and switches to this site. And maybe because of a lot of switches in this stream increase the bacterial load of some algae. Kyrkjetangen was the artificial beach. It was our second site. It was a beautiful place, but let's see, in 2 meter depth, and on the surface, the temperature was constant. The pH, if you compare the site 1 with the site 2 based on the pH, we had a basic pH at the bottom and the neutral pH on the surface too. So they are opposite of each other. We had a salt stratification at this site 2 again, but the phosphor level at site 2 was okay, and the TCB level was excellent. We had better biodiversity. At least we could find some planktons, coelacanths, barnacles, isopods, blue mussels, but not too much. Another side of Kyrkjetangen, a little bit later, further, we found a brownish rocky sediment at the Kyrkjetangen. The temperature at this site was exactly constant on the surface and 2 meter depth. The pH was like site 2, so the basic pH at the bottom and the neutral pH on the top. Salinity, wow, again we have salt water at the bottom and fresh water on the surface and salt water at the bottom. Phosphor level at the bottom was too high, and we had a good quality, good level of phosphor on the surface. TCB was excellent, and the biodiversity, but it was not so good. Better than site 1, but not too much. We only found red worms and some barnacles and blue mussels. Why is so poor? Everything seems okay. The TCB level, perfect. And the phosphor, it's okay. But why? Nobody wants to live at these sites.
Yeah. So, we had some unexpected treasures. You can say, for us it was a treasure because we had stuff to talk about. And we had actually expected a treasure chest of biodiversity. It didn't quite end like that. We found this one! Yay! And it was quite different from what we had expected. It looked really nasty and unhealthy. And this one was cute. Kind of looked like you. So we wanted to find out what was in this stream, and we found out that the municipality had done in 2008, back in time, they had done a chemical analysis, and they found, among things, heavy metals, PCB, PAH, phenols, and dibenzofuranes in this stream. And they figured out that it comes from this area here. That's a landfill where they have used a lot of fill mass, and the stream comes down here, and when it rains, all the water from the rain goes into the soil, carries with it all the chemicals, and right into the water. So we were like, that can't be really good. So they put up this sign. This is from Amitage. And this stream, for those of you who are not Norwegian, says that this stream is polluted and bathing in this bay is not advised. But it doesn't say anything about what kind of chemicals there are in this pollution. So we thought that was very bad, and they haven't done anything else, as we can tell. So we're afraid this will happen, that we have a child, and it's dissolving in this, we don't know what. So our conclusion is that it's okay water quality overall. When looking at only PCB and TCB and the phosphorus, then it's quite good values. But no, all the treatment they have used so far seems to be working very well. That they have no more direct sewage input after the turnover, and all fewer septic tank leaks, so they improved all that. That's great. And we also have that the sewage treatment facilities from the private households, so all the sewage doesn't go into Nordås, it goes now into treatment facilities and then gets undone to something better before it released. But with the lack of chemical analysis, so we didn't do that because we wasn't aware, we stayed a big question mark. Is it really that good? Because our results tells us it's pretty good, but why is it so low biodiversity if it's that good? So we believe we have unfinished business. So here we have King Harald. He's actually very happy because he lives here. What a great mansion! So, and that's right next to Nordås. It looks really great on the surface. But when we did this, we opened up a window here to how it really looks like in Nordås. It looks like that beneath the surface. You can actually swim in all the waste. But we also want to mention this to everybody that's around it, because not many people are aware, and that makes the thing very serious. We need to talk business here. But in the end, Nordås is a silent bomb. It can explode, since we also have all these chemicals. And since we don't have this turnover all the time, it just happens very poorly because of poor water exchange and poor turbulence there. We don't want it to happen at all. If it did, all the time, that would be great. Then we would have great, oxidize the water column. But a Facebook like is just not enough to fix Nordås. We have to do something more here. But the dream lives on. We want to see this when we come to Nordås next time and open it up and see what's in the surface. And that would make Kong Harald very pleased. So, that's what we had. We want to thank Caroline and Karen for her assistance, and also Lars for helping us out there and with all the information. So, see ya.